What's poppin', boys? We are back with another Psychics video with Papa Bird.
Okay.
Okay.
All right. So here's what we've got. So let's kind of talk about this. Hopefully this might answer some of your questions. Make sure everybody's on the same page. So got a pressure volume graph. Area underneath the line is going to represent
Work.
work. Because you're taking newtons per square meter times cubic meters. Area is going to represent work. So if you have if there's anything that you begin to memorize that you have to know absolutely cold for the test, okay, it has to be these definitions. Okay. Now, if you really want to plan ahead, the test over this fluid thermodynamic stuff and everything is going to be a week from today. So if you want to plan your big calendars. So you're going to have the test over thermodynamics, gas laws, buoyancy, which is going to be a week from today. Then on that last week of school on Monday, we're going to review. Then you've got your written final on Tuesday, and then your lab final is going to be Wednesday, Thursday, and then Friday we'll kick back. Okay? So that's the schedule if you want to plan long term. Okay? All right, so here's the setup. So horizontal line going across, what's staying constant?
Pressure.
Pressure. So this is going to be isobaric. Now again, if you can visualize what's happening, this goes a long way. So I've got this syringe at like 5 cubic centimeters. So as I go across, what's going to happen to my pressure? It's going to stay constant. But what's happening to the volume? Volume's getting bigger. So as the volume's getting bigger, how can I maintain the same pressure with a bigger volume? Increase the temperature. So I've got to go from Timmy to dash from the incredibles?
Yes.
Okay. So I've got a Timmy temperature here. I've got a dash temperature up here. Right? So I'm going to go from Timmy to dash. I'm going to increase the temperature. So am I going to have to dump energy into the system or take energy out? So is Q going to be positive or negative? Skittles. So I'm going to have a positive Q, so I'm going to have an inflow of Skittles. Okay? So I'm going to be throwing Skittles into the system. Volume is going to get bigger. What's going to be the sign of W? Negative. Anytime volume gets bigger, work is going to be a negative number. So I'm going to have negative work. Now, because of the fact that I've increased the temperature, remember that delta U equals 3/2 nR delta T. Anytime you increase the temperature, what's going to be the sign of delta U?
Positive.
Positive. So I'm going to have a positive delta U. So what this means is that I'm going to dump more energy in. I'm going to take some of that energy. I'm going to do work with it. But the energy that's left over, I'm going to use to increase the temperature to go from Timmy to dash. Okay? So if you can visualize what's happening. So here's this syringe. I'm going to put it in a hot water bath. I'm going to see the volume get bigger, but I've also got a pressure sensor in here, and that pressure sensor is going to stay constant. Okay? So I'm not going to change the pressure, but the volume is going to get bigger. So this is like me leaving Lenny a certain amount of money. He's got to take some of it and increase the volume to make the world a better place. Okay? Now, because this is isobaric, what formula can I use to calculate work?
P delta V, right?
Negative P.
Negative P delta V.
Negative P delta V. Because this is basically a rectangle going across. Right? Now, if I reverse the process, everything's going to change sign. I'm going to go from dash back to Timmy. I'm going to lower my volume. Work's going to become positive. I'm going to take energy out of the system, and delta U is going to be a negative number. Okay? So basically, once you reverse the process, the only thing, you just flip the signs on everything. Cool with that? Good. Okay. Now, this curved line coming down is isothermal. Now, this is the simpler one. Because it's isothermal, what's the value of delta U?
0.
0. And that's because I have no change in temperature, therefore delta U is going to equal 0. Now, delta U also equals Q plus W. So it's the only way Q and W can add up to 0.
Equal and opposite.
Equal and opposite. Volume is getting bigger. Volume is getting bigger. What's the sign of work? Negative. When volume is bigger, work is always negative. Now, to get my work, can I use negative P delta V?
No.
Why not, Michael?
It's NRT, natural log of.
But why can't I? But this is so simple. It's cute. Negative P delta V. It's so much simpler.
Changing pressure.
Yeah, I don't know which pressure to use. Okay? Do I use my initial pressure, my final pressure? I don't know. Now, Michael, you're right. Okay? What I'm going to do to get this work is I'm going to use NRT, natural log of volume initial over volume final. And I will give you this formula. Okay? Do not memorize this formula. I will give you this formula. Okay? And I will give you that 3/2 NR delta T. I will give you that formula as well because it's not on your equation sheet. Okay? I will give you those formulas. Now, but here's the whole kicker to here. Because the volume is getting bigger, my initial volume is going to be less than my final. So I'm going to take the natural log of a number less than 1. That makes the natural log of a number less than 1 a negative number. Therefore, I end up with negative work. Okay? And that's why that fits. Which work is going to be bigger, the isothermal or the isobaric? Which is going to require more work, isothermal, isobaric?
Isobaric.
Why?
Because it's a rectangle with bigger.
Yeah, just look. This area up here is a lot bigger than this area is down here. Okay? That's going to take a lot more work. Okay? And if you do the math, like we did yesterday, it's about twice as much. Because you can just look at it and go, oh, that's about twice as much, twice the area. Okay. Now, last one is isometric. Sometimes it's called isovolumetric. It means the same thing. Okay? So here's pressure, here's volume. Let's say you're up here at 1.2 times 10 to the third, times 10 to the fifth, newtons per square meter, and a volume of 0.03 cubic meters. But we're going to go down like this. So as third block just push it, we had a dash up here, right? So this one, we're going dash to crash. Because what do I have to do to get to this point? Increase the temperature or decrease the temperature?
Decrease.
Decrease it. Now, here's what's cool about this. And this is why this is the simplest one. What do you not have to worry about?
Area.
You don't have to worry about volume. Okay, so therefore, without any change in volume, what's my work value?
Zippo.
0. Okay, I couldn't calculate the work if I had to. There is no work because there is no area. So, now, here's what's going to be different. Okay? And this is the whole point of the lab that you're going to do. What I want you to visualize here is that with these, you have to have a movable system, like you have to have a syringe. You have to be able to change the volume of the system. Pull the plunger out, push the plunger in, something like this. So, if you have like a sealed system, like a can of pop, you can't have either of these because of the fact that it's a sealed system. Now, over here, isovolumetric, this is where you could use like a can of pop or something where you're not changing the volume because it's a sealed system. And sometimes, and like in the lab that you're going to do today, you're going to have some systems where you're going to change the volume, and you have other ones where you're going to lock that volume in place. Okay, so here's the setup. So I'm going to go from 1.2 times 10 to the fifth, and then we're going to end up here at 1.0 times 10 to the fifth. Now, without crunching the numbers, what's got to happen to the temperature? Increase, decrease, stay the same.
Decrease.
Decrease, because look, you got PV equals nRT, right? So I got PV equals nRT. Over here, what's happening to the volume?
It's constant,
Constant. What's happening to the pressure?
decreasing.
What has to happen to the temperature?
Drop.
So the only way this can happen is this is removing, I'm taking the Skittles away from the kids, okay? As a matter of fact, they've eaten their Skittles and now they're on that sugar low, okay? They've peaked out. Now they're like, oh, it's nap time, right? So we've gone from dash to crash. Temperature has dropped. So again, look at how you can change the pressure of a system. You can change the number of collisions or you can change the kinetic energy of the collisions, okay? So in this situation, I'm dropping the temperature. So the collisions probably aren't going to be happening as quickly because the kids are kind of run down, and the ones that do hit the wall aren't going to be moving as quickly. So has energy flowed in or energy flowed out of the system? Thank you. So,
Last session.
Q here is going to be a negative number because of the fact that I've got energy, I'm going to take energy out of the system. Temperature is going to drop. What's going to be the sign of delta U? Positive or negative?
Negative.
Negative. So I'm going to have negative delta U because of the fact that I'm dropping my temperature. So hopefully now you can look at this and go, oh, that isn't so complicated after all. So if you keep in mind like a visual about what's happening, this becomes a relatively easy, simple system. So now here's what's odd about this. Okay, so let me kind of put all three like on the same graph. Okay? So on all of these, no matter what, Q is never a non-zero number. The one thing that's going to happen on all three of these, Q has to be a non-zero value. You can have work being 0. You can have delta U equaling 0. But you can never have Q equaling 0. So what that means on any system, you have to figure out, is Q positive or is Q negative? Now, the other thing about this is prepositions. So when this volume is getting bigger, we say that work is done by the system because it's making this gas is expanding. So that's like when you take your hand, like we did yesterday, and you blow on it when you pucker your lips and it feels cold. Work is being done by the system to expand and it costs it energy. If you reverse this, we say work is done on the system, okay? Because we're going to compress this thing down and we're going to increase that internal energy. So what's happening here, this is what happened when I did fire syringe. I very, very quickly decreased the volume of that, okay? As I decrease that volume, I'm doing work on the system. It heats up. Wow, we can ignite the system. So here I've got no change in temperature. Q is going to be positive or negative depending on which way you go. Q is positive or negative when you go this way. So it's possible to have delta U be 0. It's possible for work to be 0. It's never possible for delta U to be 0. So heat is always going to flow in or out. So you always have to put it in an ice bath or you have to warm it up. Cool with that. No pun intended. Good? Okay. Now, any questions on the assignment itself? We're good? I like this. Now, let me give you some hints, okay? So, and this is kind of conceptual and make, because I just know what's going to happen, okay? So, like, if you get, like on 15, an ideal gas expands isothermally, da-da-da-da, okay? Now, here's what I want you to look at. I got 3.4 times 10 to the third joules of work. I'm just giving you the number. You have to decide if that's positive or negative. All I'm giving you is I'm just saying, here's the number. You have to decide if it's positive or negative. So this is where it's a situation in terms of prepositions. So if you look on 15, I said it expands isothermally. It's going to expand, okay? It's going to expand. What's going to be the sign of your work?
Negative.
Negative number, okay? Now, if I had said an ideal gas is compressed isothermally, and then I would say, while 3.4 times 10 to the third joules of work is done on the gas, okay? So this is why you have to understand the prepositions that are used in thermodynamics. If work is done by the system, that's the magic code for the volume gets bigger. If work is done on the system, that's the magic code for the volume is getting smaller. Okay? That's what you want to look at. Anyway, so make sure on 17 when you're drawing that diagram, it doesn't have to be exact, but I kind of want, a sketch on what's going on with that. So on 16, your first answer on 16 should be to the 5th, and your second answer on part B should be something times 10 to the 6th. Anything else? Now, it's an interesting thing. Let's talk about your answer to A on number 1. How many joules were equivalent to the 230 calories, okay? And how many times did you lift a 50 kilogram mass, okay? So what you should see on that one is if you use that and lifting that up, you should get like a pretty big number, like around 250, okay? So that's kind of cool if you think about it. It's like, wow, if you could
go pump some
take that energy, yeah, okay, and that's, wow.
You just go dumb.
Okay, this wasn't about power, this was
Pump
just
the
number
iron.
of times.
Pump the iron.
Okay, pump the iron, pump it, pump it up.
Yes,
Okay,
sir.
anything else? Once, twice sold,
Wait, okay, sorry.
okay,
On
It's not
17,
right
so
yet.
17.
On what?
On 17, were you wanting like a sketch or were you wanting like a graph? Like,
well, it's just gonna drop, like, pressure, volume, and then like, it's good, you don't have to have the exact numbers on it.
Okay.
But you do want to put like some arrows indicating which direction it's going, like are you going up on the isothermal or down on the isothermal? On the isobaric, are you going across, or are you going to the right, or are you going to the left? Okay, that's what I meant.
sounds good.
Okay. Anything else? Once, twice, sold? Okay,
Calling it good.
so
Bye bye, everyone.